Hello, my name is Lauren Christopher, and I am an MPH MS student in the Department of Anthropology at Purdue University. I hope everyone is doing well today, and I'm excited to connect with you all in this new virtual space. I know it's not ideal, but I am very excited to be able to communicate with you guys about human growth, and I'm excited to see your talks later on this session. Today, I will be talking about the growth of the Yucatan Maya children in rural and urban settings, and how early life factors can affect growth outcomes later in childhood. I will begin with an overview of growth malnutrition studies and recent findings of how growth is affected by changing nutrition and health practices in countries undergoing nutritional and epidemiological transitions. I will then focus on the Yucatan Maya, one of the largest indigenous groups in the Americas, and recent developments in growth and birth practices. We will then dive into our cross-sectional study that asks the following questions. Question 1. How does the Yucatan Maya children's growth compare in rural and urban settings? Question 2. Is their growth correlated with early life conditions and modernizing influences? And question 3. Is child growth changing over time? In 1990, the World Health Organization had added reducing the under 5 mortality to the Millennium Development Goals. Malnutrition, most often in the form of protein, was the most common cause of under 5 mortality. Reducing malnutrition became a top priority. Under 5 deaths are connected with poor nutrition, late supplementation, lack of maternal care before and after birth, and high rates of infectious disease. With protein supplementation and pressure for inclusive or universal health care, the mortality rate for children under the age of 5 has progressively dropped. In addition, there has been a drop in stunting overall. Stunting has been used as a chronic indicator of malnutrition on growth and development in children. Children who are stunted tend to be shorter in height for their age. Stunting is associated with increased risk for poor cognitive function, poor performance in school or in future employment, higher risk for anxiety and depression, higher risk for chronic disease, and overall higher morbidity. Although this is an important measure, there are legitimate issues with this generalization that stunting provides. It does not account for human variation in growth among short-statured populations. In addition, stunting as a measure to indicate the nutritional status of a child does not capture other forms of malnutrition, such as obesity. Obesity can have similar chronic outcomes as stunting and is associated with the epidemiological transitions in the last century. Usually, stunting is defined as 2 standard deviations below the mean height Z score for the age group. The standard mean in the growth literature is dominated by Western growth statistics, and as we will see later in the talk, there is a need to standardize the average height within the populations we are working with. Even with using World Health Organization standards, my kids come up a bit short. It's a little height humor for you in APA talks. With that said, due to recent efforts to reduce malnutrition under 5, we have seen a reduction in stunting prevalence on a global scale. In the last 17 years, there has been a reduction in stunting prevalence, with most of the strategies targeted at supplementing severely malnourished children. In some cases, early supplementation has also been an effective strategy, such as egg supplementation in Ecuador. As we see here, there's also a reduction in mortality due to malnutrition. At the same time, severe malnutrition is being addressed on a global scale, as well as in Mexico. Mexico has a decline during this time. The arrow here is pointing to a light blue dotted line that represents Mexico's under 5 mortality due to malnutrition, as provided by the Institute of Health Metrics and Evaluation at Washington University. During this time, Mexico was undergoing an epidemiological transition, and a shift in cause of death in health practices was captured in this data. During the last 30 years, there has been a reduction in enteric infections, nutritional deficiencies, and other infections as the cause of under 5 mortality. There's been a rise in non-communicable disease during this time as a cause of death, while maternal and neonatal deaths still remain the leading cause of death. This is mainly due to 2 major events in the last 30 years to revise this health system. The first, in 1998, the program Oportunidades, which introduced in 1998. This was a pilot cash flow transfer program where citizens were randomly enrolled within an 18-month period. A total of 506 communities were enrolled, and by 2003, a sample size of 3,793 children were enrolled for their entire lifetime. This program supplied food supplementation, school supplies, and when applicable, and a monthly allowance calculated based on family size and age in return for families attending checkups and allowing the country to collect their data. In 2000, there was another overhaul of the health system with Seguro Popular, the secondary healthcare system as designed to cover people who did not have a salary in Mexico, and provide access to healthcare to more people across the country. This transition is generally good for extending the length of life and risk of infectious disease, but there are many unanswered questions about how sociopolitical factors change health behaviors or create other health concerns such as childhood obesity, which can also lead to a risk of chronic disease later in life. During the last 30 years, there have been increased reliance on cesarean births in urban living. There have been recorded changes in how people are living in each household, as well as the type of dwelling that they occupy. Previous research by Wiley, Valegia, and Kramer have shown that during this transition, there are differences for children aged 24 to 48 months with a sample size of 113 between the Maya and the Argentine Toba. The Maya are much more shorter and lighter than the Toba children. In this case, they had data collected from the Toba in Argentina. These predictive models show that in the Maya and the Toba, children with a cesarean delivery were more likely to be heavier and exceed the World Health Organization standard median. Which leads us to our research. Our hypotheses are the following. Early life factors will be associated with anthropometry in Yucatan Maya 6-year-olds. The high birth weight, cesarean delivery, and being from an urban setting will be positively associated with anthropometry. Rural and crowding index, which refers to the number of people in a household, will be negatively associated with anthropometry. Now a little bit about the Maya. The Yucatan Maya are one of the most extensively researched and also one of the most extensive research partnerships with anthropologists. Robert Redfield was one of the first anthropologists to do collaborative ethnographic work with the Maya and started some of the first research sites in the Yucatan. Since then, there have been extensive research with the Maya, and our data particularly come from Mayan 6-year-olds from the cities of Merida and Mutol. They came from several different public schools and socioeconomic strata, but all were identified as Maya based on their surnames. They did not differ significantly in relevant variables, so they are merged to form the urban sample. The rural sample comes from Maya 6-year-olds from a well-studied subsistence farming community with a population of 500 in the Puke region of the Yucatan Peninsula. In the last 20 years, a traditional diet and agricultural lifestyle have been maintained while electricity, running water, and labor-saving technology were introduced. Maya is the predominant language in the household, though most people now speak Spanish. Due to the humid climate and the limited sanitary infrastructure, pathogen exposure is high, and children have physically active lifestyles. Data were collected in the urban communities from 2011 to 2015, and the rural community from 2010 to 2017. Birth weight and birth mode were collected by maternal interview and verified with medical records when possible. Data on family size and number of bedrooms to calculate a household crowding index were collected. Furthermore, participants' height, weight, and tricep skinfolds were then measured by trained research personnel following standardized procedures. And of course, Z scores were calculated using both the standard and World Health Organization equations. All analyses were done in RStudio. Descriptive statistics were completed using base operations in R, in addition to using the Dippler, Tibble, Plier, and ggplot2 packages. All regression analyses were completed using the Luberdate and Dippler packages. Here we are showing a diagram just to show the directionality of our variables here. We definitely want to see the cesarean delivery rate was 47% urban versus 21% rural. There were positive associations between maternal height between urban and rural communities, while birth order and crowding index were negatively associated between urban and rural samples. Triceps height and weight were positively associated between urban and rural communities, and the rural and urbans were significantly taller and had higher tricep skinfolds and BMI compared to the rural children. We then calculated the Z scores for both height and BMI using the World Health Organization standard equations and found significant and positive associations. Here, as you can see, between the two groups, City 1 and City 2, which are our rural samples, And city 3 are urban samples. We found significant differences for height. Urban groups tend to be shorter than their rural comparisons. Here, also, with BMI, urban children tend to have lower BMIs than the rural children in the dataset, and Skinfolds also reflect these differences in lower BMI as well. We also did regression analysis for interaction data. The only variable that was significant was our generalized linear model for height. It was significant, but only slightly. These data further establish effects of an epidemiological transition and show that children born in urban settings are smaller than their rural counterparts. Crowding index is a significant correlate, shows that housing has changed with lifestyle. In addition, cesarean versus vaginal birth mode significantly is different between these cities, showing that there is a small interaction and that there is more to these transitions than we understand. And we must be more specific when we work in populations and make claims about how these transitions are affecting children on a mass scale. There seems to be a nuance between lifestyle and the type of access to a household that they have. In our future work, we will be combining these data sets with data from our age 7, age 8 categories, and also we will be modeling our data using Bayesian statistics so that we can look at changes within an individual over time using precursor knowledge and precursor data. These are our selected references, and I am here if anyone would like to take any questions. If you are watching this recording, thank you so much for watching, and you can contact me at the email here. Have a nice day.